Hello. So one last thing to do with integrating and differentiating for exponentials and logs is what if it's not e to the x but something else. Okay. So the reason we use e to the x as a general rule is because the derivative of e to the x is e to the x. So the integral of e to the x is e to the x, and also because the derivative of log x is a nice just 1 over x, nice and simple, and so the integral of 1 on x is log x. So that's why we use those powers and bases. Sorry, bases I should say for both of them. So let's think about what if instead of e we used a for some other letter a. A must be positive, it doesn't make sense otherwise. So a to the x, what does that look like? Well, it just looks like that, right? That's still 1. Oh, sorry. Wrong one. Yeah, it looks like that. Okay, that's still 1. But the only difference really is that when x equals 1, we now have y equals e, whereas before we would have had y equals a. Whereas before we would have had y equals e. Okay, so you can see there that it basically looks like e to the x, right? E to the x does the same thing, but it might be steeper or flatter depending on how big a is. So you'd think the derivative would look roughly the same, right, as well. And we do the same thing for log base a of x. Well, it's not immediately obvious, but basically, if this is a to the power of x, then log base a of x looks like that. It's just a reflection in the line y equals x because it's the inverse. And again, it looks basically the same. It's just steeper or flatter depending on the value of a. So again, you'd expect the derivatives to be the same. So let's work out how to actually differentiate a to the x. So we've got y equals a to the x. We know what to do if it's e to the x or something like it. So what we do is we actually rewrite a. And we rewrite a as e to the power of log a. Okay, because e and log are inverses. If I do e to the power of log, I just get back to where I started. That's an important thing to know. So if you didn't know that already, e to the power of log x equals x, and similarly log e to the x equals x, because they're inverses. Okay, so we get this, and then we just rewrite it. And now, this is just e to the x times something. So it looks something like this. And we know that when we differentiate this, we leave the e to the x alone. And then we just multiply by the derivative of the power, which in this case is log a. Okay, this bit here, the highlighted bit, is exactly a to the x, because it's exactly that. And so we get the derivative is a to the x times log a. Okay, now you do not have to remember that. Okay, you don't have to remember that as a rule. It's not a rule per se. You do need to know how to do it, so you should kind of familiarize yourself with the method. And so we can basically then do the same thing with log base a of x, and we can say, well, log base a of x using the change of base formula, which remember says the base goes to the base, and we change it to log base e, so we get log base e of x divided by log base e of a, and the base goes to the base. And so then the derivative of that, log base e of a is just a number, so it's 1 on log base e of a times the derivative of log x, which is 1 over x. And you can rewrite this as 1 on x log base e of a. Again, not a rule, not something you could memorize, but a method that you should memorize, I suppose, or be familiar with. Okay, so basically then we're just asked to do exactly the same thing here. So express y equals log base 5 of x. in terms of log base e of x, both log x and log 5. The base goes to the base. So I'm not actually going to do this because I didn't bring my calculator home. But log base 5 of 30, it's going to mute my phone, sorry, is log 30 over log 5. It's a number on your calculator. It is not log 6. Okay. This one is log 2 on log 5. This one is log 0.7 on log 5. So for part C, basically what it's saying is if log base 5 of 30 is y, then 5 to the power of y should be 30. So put this number here. I'll use my phone calculator, which will probably take me half an hour to work out how to do. Firstly, you've got to find your actual phone calculator, and then you've got to work out how to put it into, there we go. Sorry. Log 30 divided by log 5. So you should get 2.11 something or other. So then 5 to the power of 2.11 should be 30, which makes sense. 5 squared is 25, so 5 to a number slightly bigger than 2 should be 30. Okay, use the change of base formula to differentiate. So just like we've been doing, the base goes to the base. Log base e of 2 is just a number. It's 1 on log 2 times 1 on x. The base goes to the base. So the derivative is 1 on x times 1 on log of a, which I could tidy up as 1 on x log a. Again, you don't memorize, but you can certainly use. Okay. This is getting very repetitive, so I'm actually going to stop here. But this one will just be 1 on x log 10, 1 on x log 1.05. Okay. So let's do this one. Show the tangent at the x-intercept. Okay, so that's when y equals 0. So when y equals 0, 1. We know that the derivative is 1 on x log a. And so we can then say that this is y dash is 1 on 1 log a, which is exactly what we wanted. And then it says, show that that's the only logarithmic function whose gradient is exactly 1. Let's be saying solve this. 1 on log a. 1. Log a equals 1. A equals e. Done. Okay. Alright. Most of that's pretty boring, so I'm just going to skip all the way to here. I don't think any of that was really useful. So, show that this line meets the curve. I'm just in the interest of making it a shortish video. Meets the curve 2x there and there. Okay, so for part A, x plus 1 is 2 to the x. 0 equals 2 to the x minus x minus 1. When x equals 1, sorry, 0. So I'm just going to sub in the points and show that they work. It's 2 to the 0 minus 0 minus 1 equals 0, tick. And we get y equals 0 plus 1, tick. Okay, so that gives me 0, 1. When x equals 1, the right hand side is 2 to the 1 minus 1 equals 0, tick. Y equals 1 plus 1 equals 2, tick. So that tells me that 1, 2 works. Sketch the two curves and shade the region in between them. here's 2 to the x. So it meets at 0 and 1 for x, right? So that's going to help me when I draw the other thing. So there's the shaded region between them. The line is on top. It says find the area of the shaded region. So the area is the integral from 0 to 1, because that's where they intersect. Top, which is x plus 1, minus the bottom, which is 2 to the x. So, just like we were doing before, we rewrite 2 as e to the log 2. Okay. And now we integrate as normal. And then we substitute in. Like so. So this gives me 1/1/2, 3/2, minus 2 over log 2, plus 1 over log 2. So it's 3/2 minus 1 over log 2. It says 4 significant figures, but you can use a calculator just fine. Okay, there's homework at the top. See you later. Hope you enjoyed YouTube.